In this recording, I'm going to show you how to do a simplified Lewis dot structure, a way to draw molecules. And I say simplified for a reason. I'll give some examples possibly during the video. But when you draw these molecules, you need to use the instructions that I'm giving on this video. One of the reasons is uh, that helps me ensure that you did not look up how to draw these molecules on the internet. It would be easy to just do, take one of those chemical formulas and Google it, and that's what you're not supposed to do because you need the practice. Not necessarily drawing molecules, because if you're not a biology major, you're probably not going to have to draw molecules um, throughout your life. But this is the purpose of this is to help you understand how organic molecules are basically put together specifically, and you'll see how this works once actually start showing you. But one of the main things you need to understand is carbon can bond 4 times, nitrogen can bond 3 times, um, oxygen can bond twice, and hydrogen can bond once. So again, I'm going to show you how to draw some molecules. I'm going to do a simplified version. And it's also worth noting that when I show you how to draw these molecules, for a lot of these molecules, there's different ways to draw them. And in all actuality, some of the ways I'm going to draw them will suffice for this lab, but in real life, the molecule wouldn't actually look like that. So again, imagine carbon can bond 4 times, nitrogen 3 times, oxygen twice, hydrogen once. So when you have a large molecule, there's so many different ways that you could draw them using those rules. And those are really the only rules you need to stick with. So keep that in mind. I'm not showing you specifically how to draw molecules the way they actually are in nature. I'm showing you how to complete this assignment. So with that being said, let me share my screen and we'll take a look here. Let's see here. First thing we're going to look at is the lab. Excuse me. Yeah, I'll just share my entire screen. That would be easier. So Google Docs does allow you to draw things, and I'm going to use that method. That way you can also use that method, or you can do it on, with pencil and paper and take a picture and insert that into your document. But let's take a look here. So, I've shown how to do these two, or you can see the results of these two, but I'm going to show you how to do those, and then I'm going to give you some other examples. So the first thing I need to do is remember how to bring up the drawing portion. Actually, I'll do it this way. Okay. Like that. Google has changed this up on me, so I've got to, there we go. Here's what I'm looking for. Start a new whiteboard. Here we go. So the first example on the lab here, if I remember correctly, was hydrogen peroxide, H2O2. Yep. So I'll write this. Now keep in mind I'm using a mouse, so you have to forgive me for how sloppy this is. But here we go, H2O2. This one's an interesting example because there's no carbons, and most of the ones we're dealing with have carbon in them. And as a matter of fact, my most valuable advice will be dealing with carbon, but we'll get to that once we get to those kind of molecules. First, let's just look at this one. I'm just going to draw it out. I always do hydrogens last. The first thing I want to do is my oxygens, right? So I'm just going to put those 2 oxygens, and you'll see, I'll explain why later, why I do my hydrogens last. So I've got my 2 oxygens, got my 2 hydrogens. All right, now we're just going to connect the dots, right? Because that means there's a bond there. So there we go. At first glance, it looks like I'm done here, right? Everything's bonded to themselves. That looks to be good. But we have a problem. As I mentioned earlier, oxygen can bond twice, or has to bond twice, if you will, as far as we're concerned in this course. And hydrogen has to bond once. So here we have this oxygen that does not have enough bonds, right? Because it only has 1 and it needs 2. But the good news is we have this hydrogen. Whoops, excuse me. Wrong one. We have this hydrogen that has too many bonds, right? It has two bonds and hydrogen can only have one. So this is going to be an easy solution, right? I'm going to take this hydrogen and I'm going to put it right over here, right? So let me erase all that I've just done. Some of it that I've just done, right? Let me erase this. I'll erase this. All right. So again, we are taking this hydrogen and we're moving it over here, right? So I will erase this hydrogen and its bond. And I guess might as well erase that little line since it's no longer pointing from something. Okay, there we go. Add my little hydrogen right here. And boom, we're done, right? Two hydrogens, two oxygens. Both oxygens have two bonds, and both hydrogens have one bond. So that is how you draw H2O2. Now, let me start completely over. Let's look at another example. Go back here. The next one is CH4. This is methane, a very simple example. So again, you don't have to write out the formula. They're already given to you, but I'm going to go ahead and write mine out so I know what I'm working with. CH4. There we go. Again, this is a silly way to do it, but I'll go ahead and do it this way first. Again, just carbon, hydrogen, two hydrogens, three hydrogens, four hydrogens, right? So there we go. I put them all in a line, and there we go, right? But if you look, like that's silly, right? And what I do know that I mentioned earlier is carbon bonds 4 times and hydrogen only bonds once, right? So instead of drawing it the way I just did here, a better method would be, again, if I'm going to just start completely over, since now I'm finally dealing with carbon, unlike the last example, I have carbon. So what I'll always do once I'm using carbon is put down all my carbons, and then I will surround my carbons, right? And because I know, again, carbon can bond 4 times. So I'll just go ahead and draw those 4 in, right? All right. And now my hydrogens, I need 4 of them. So, oops, 1, 2, 3, 4. And that's it, right? This carbon has 1, 2, 3, 4 bonds. Each hydrogen only has 1 bond. So that is correct. I will point this out too. Again, if you were to look this up and how to, draw these more accurately, there are different ways to draw this where you could show the 3-dimensional shape of this molecule, right? Because this is flat on a piece of paper. Well, a simulated piece of paper. But in all actuality, if you're doing real chemistry, so to speak, you would show its 3-dimensional shape. But we don't have to worry about that, right? I just want you to draw it just like this. All right, let me clear this and do some more examples. Going back to the lab. So those are the only 2 examples that I gave there, but I have pulled some up and I did just look, I just typed them in. I haven't studied them or anything. So let's look very quickly. We have, all right, C3H8O3. So C3H8O3. So again, like I said, I start with the carbons because these are biological molecules, right? So these are all carbon based. So everything I do is going to be based on the carbons, right? So 1, 2, 3. I've got my 3 carbons. Now again, now I'm just going to surround my carbons, right? And I'm going to do hydrogen last because hydrogens are easy to move around since they can only bond once. So here we go, oxygen. Got 1 there, 1 here, 1 here. That's all my oxygens. Good. So now I'm just going to keep going clockwise and keep surrounding my carbons. So I've got 1 hydrogen here. That's hydrogen number 2, hydrogen number 3, hydrogen number 4, hydrogen number 5. Kind of running out of room here, but hydrogen number 6, hydrogen number 7, and hydrogen number 8. Now, this is a good example only because it was simple, right? So again, once you've drawn them, then you have to check and make sure everything's good as far as the number of bonds is concerned, right? So we have carbon can have 4 bonds. So this carbon has 4 bonds. This carbon has 4 bonds. This carbon has 4 bonds. That checks out. Oxygen needs 2 bonds. So we have 1. This oxygen has 2 bonds. This one has 2 bonds. This one has 2 bonds. And of course, hydrogen can only have the 1 bond. And as you see here, all those hydrogens have 1 bond. So there we go. That's another example. That one was an easy example. Hopefully this one's a little bit a little bit more difficult. The next one, C12H22O11, right? So we're getting a little bit harder here. C12, I believe I said H22. H22, and then O11. So this one will only be harder in that there's just more to draw, right? This is a large molecule. So here we go. I'm going to do my 12 carbons because, again, I'm going to start with carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, sorry, 11, 12. All right. Good grief. Sorry about that. I've got my 12 carbons. Now, again, I'm going to surround my carbons that are all should have 4 bonds. And again, I'm going to do hydrogens last. So oxygen, there's 11 of them. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. Now, again, we still have 22 hydrogens to deal with. So I'll keep surrounding my carbons. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And I like this example because not only was it long, so that made it a little bit harder for me to show you these things, but now there's some problems, and I'm going to show you how to fix those problems. So we know we have 12 carbons, 22 hydrogens, and 11 oxygens. But then we have to check this, right? Do all of our carbons have 4 bonds? Do all of our oxygens have 2 bonds? Do all of our hydrogens have 1 bond? Well, I know all the hydrogens have 1 bond. I just put them there. But let's look at this. And also, I know all the carbons have 4 bonds. Excuse me, that's not true. Oh, this is good. Okay, so this carbon, it only has 2 bonds, right? This carbon only has 2 bonds. That means it needs 2 more, right? This oxygen, it only has 1 bond, but it needs 1 more. This oxygen only has 1 bond, so it needs 1 more. So now we're going to start what I like to call fix a problem, create a problem. And you just keep doing that until you've completely fixed it, right? So let's see here. I'm going to double bond this carbon to that carbon. So that way I can have at least, again, I'm trying to get 4 bonds around this carbon. So now I'm 1 closer. 1, 2, 3. I still need 1 more. But here we go. I wouldn't say I fixed 1 problem, but I got closer to fixing this problem. And I created another problem by double bonding these carbons. Now this carbon has too many, right? It has too many bonds. 1, 2, 3, 4, 5. Good. So why don't I just take that oxygen, take this oxygen and move it away from this carbon and move it to this carbon. Okay, good. Now my carbons are fixed. This carbon has 1, 2, 3, 4 bonds. This carbon has 1, 2, 3, 4 bonds. We're getting there. But now here's our issues. This oxygen doesn't have enough bonds. This oxygen doesn't have enough bonds. So once again, fix a problem, create a problem. I'm just going to go ahead and double bond this carbon to that oxygen. Boom, that oxygen's good to go now, right? It has the two bonds. But now, again, I've created a problem because now this carbon has 1, 2, 3, 4, 5 bonds, and it can only have 4, right? So let's look at the problems. The problems are this carbon has too many oxygens. This oxygen, excuse me, I'm sorry. This carbon has too many bonds. This oxygen doesn't have enough bonds. So here I see a simple solution here. If this carbon has too many, this oxygen doesn't have enough. Let me take a hydrogen away from this carbon. So that carbon is now fixed because it has 4 bonds. And then we will add that hydrogen over here. So there we go. Now everything is good. All these carbons, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All these carbons have 4 bonds. All these oxygens, 2, 2, 2, 2, right? All the oxygens have 2 bonds. And that's how you do it. Now the examples I gave you didn't have any nitrogen in them, and some of the ones you're going to do have nitrogen in them. And it is worth noting again, nitrogen can bond 3 times. But that's how you're going to do it, right? To recap, I recommend drawing out all your carbons and then start surrounding them with everything else. Then, connect the dots, look at all your bonds. And then once you've done that, then make sure all your carbons have 4 oxygens, all your oxygen, I'm sorry, I cannot talk today. All your carbons have 4 bonds, all your oxygens have 2 bonds, all your hydrogens have 1 bond, and all your nitrogens have 3. And that's how you do it. This is also a good time to remind you, you don't have to do this alone. Yes, I'm making a video so you can do it alone, but this is the lab. And in a normal situation, you would work in a lab with fellow students and an instructor. So, again, if you need me, or I guess anybody else, but specifically me, if you need me, contact me. We can meet either in person or online, and we can do these together. But yeah, that is how you do it. And good luck.